Aloha and welcome to our video on the solar system. In this video, we'll look at the differences between terrestrial and Jovian planets, and we'll also explain how the solar system formed. In this picture, we're taking a look at the solar system as an entirety per se. And what I want you to do is I want you to realize we have a heliocentric model, so our sun's here in the middle. We then have our 4 terrestrial planets, that would be Mercury, Venus, Earth, and Mars. And then beyond that, we have the asteroid belt. Beyond that, we have our 4 Jovian planets, which would be Jupiter, Saturn, Uranus, and Neptune. And then we have our dwarf planet of Pluto. And we'll be talking in the upcoming videos about these different planets, but let's take a look at some basic facts here real quickly. So in this slide, we have a picture. Remember, we have our 4 terrestrial planets here, and then we have our 4 Jovian planets here. Pluto is a dwarf planet, but a lot of times it's kept in the loop of the planets, so we can use it as a comparison against other things. As we look at our planets in the chart here, some of the things you'll notice, we have the known satellites. That's as of 2006. So we'll see that we have 1 around Earth, the Moon. We have 2 around Mars. Then we have 63 at Jupiter, 56 on Saturn, 27 on Uranus, and 13 on Neptune. Pluto has so many because it hasn't completely cleared the orbital field, so we see some debris there. So we can kind of see a little bit of differences there as well. We'll talk about the planets a little bit more. They'll cover them in the lesson, so I don't want to spend a lot of time going through the rest of the data. But you can kind of see how long it takes it to go around the sun, how long does it take it to rotate on its axis, and then we can kind of look at the sizes relative to Earth here. So how did the solar system form? Well, we believe in the nebular hypothesis, and what that means is that we had a nebula, or a cloud of gas and dust that was out in space, and we started to have some coalescence in the center of this. So we'd have gravity taking place, and it would pull together, make larger pieces, more gravity, pull together more pieces, and that nebula would rotate in time as well. So we see a little bit of this rotating gas cloud. And what we're going to notice is here in the middle is where we're going to have the formation of our star, and that's going to be the sun. So as we look here, we're seeing the formation of the sun here, and we have the remnants of this nebula are still going to be flattened out into a disk. They're going to be rotating in that. And as they're rotating, they're going to bump into other pieces, and we're going to have that gravity occurring, and we'll form what we call planetesimals. And planetesimals are going to be these larger particles still traveling in a disk-like area. They'll start to congeal into these rings, which are our orbital rings here. And we'll see this process go until we actually have the formation of planets. So if we get one slide with all of this, we can start with our nebula here. We start down, we form our protostar. Once we have our star formation here, we have our leftover material in this flattened out disk shape that's going to start coalescing into planetesimals, which you can kind of see here, just larger bodies going around. And then once they clear that orbital path, then we end up with our solar system here. And we'll talk about the different pieces and parts in future videos. As always, good luck with your quiz, and we will see you in the next video. Aloha and welcome to our video on the terrestrial planets. In this video, we'll take a look at Mercury, Venus, and Mars. Notice we're skipping Earth because we've already spent a lot of time in this class discussing Earth and its properties. So let's take a quick look at Mercury. As you can see, a day on Mercury is 58 Earth days long, and it takes 88 days for Mercury to travel around the sun, so it's moving a little bit faster. Speaking of the sun, if you looked at the sun from the surface of Mercury, it would appear about 3 times larger than it does here on Earth, and that's going to create a much greater variation in temperature on the surface. In fact, you can have 1,000-degree variation of surface temperatures on Mercury. If you look at the surface, you'll notice that it is a lot of craters. We see some of these like valleys and grooves and things like that going through, so it's been impacted quite a bit. It is the smallest of the planets. We do have some smaller dwarf planets, but Mercury is going to be the smallest of all of our planets in the solar system. So let's take a look at Venus. Now, Venus is an interesting planet. It's actually the warmest of the planets because it's covered in such a thick blanket of carbon dioxide. So it's fully experiencing the greenhouse effect there. So it's a lot warmer on Venus. These clouds also prevent us from being able to see the surface of Venus. So we can kind of do it with a cloud penetrating radar as we traveled by. Venus has a year of 225 days, and its day, its sidereal day, is negative 243. Now the reason I call it negative 243 days, it's actually 243 Earth days for it to line back up. But I put the negative in there to remind me that Venus, in fact, spins the opposite way. So if you're on Venus, the sun would rise in the west and set in the east because the rotation of Venus is backwards. So a little bit of a different thing on that planet there. Okay, so let's take a quick look at Mars. A day on Mars is 24.62 hours long, so it's roughly the same as ours. The year, however, is 687 days, so it's 1.8 Earth years for it to go around the sun. Mars is a planet of extremes, so if we look at Mars, you can see right over here, we have what we call Valles Marineris, and that is a canyon that makes the Grand Canyon look tiny. It extends out much larger than that. There's also the largest volcano on Mars, that would be Olympus Mons. One of the things we notice with Mars is we have these ice caps here. So we believe that water was once on Mars, and that's kind of what we're looking for. We feel if we can find water on Mars, then we may be able to find life on Mars as well. Okay, so the lessons will go through a little bit more information on each of these planets for you. It's just supposed to be a quick overview. As always, good luck on your quiz, and we'll see you in the next video. Aloha and welcome to our video on the outer planets and Pluto. In this video, we'll take a look at Jupiter, Saturn, Uranus, Neptune, and Pluto. So let's take a look at Jupiter. Its day is about 10 hours long, and its year is 11.6 years. And its year is a lot longer because it has further to go because it's so much further away from the sun than the Earth is. The volume of Jupiter is 1,321 Earths, so it would take that many Earths to have the same volume in space, but its mass is only 318 Earths, so its density is going to be a lot less, and that's because it's a thick atmosphere planet. So we call them the gas giants because they have such a thick atmosphere on them. Jupiter has 67 moons, and it does have a ring system, but it's very faint, so it's not as pronounced as, say, Saturn, which we'll see in the next slide. Another interesting thing about Jupiter is the red spot here. It is a large storm system that's bigger than the Earth, and it's been raging for a long period of time. So it's a surface feature that you can actually see through a telescope. So when we talked about Galileo, we talked how he turned his telescope to Jupiter and he was able to see 4 moons. And these are the Galilean moons. Now the Galilean moons can be seen by a good pair of binoculars or by a telescope. There are 4 of them. They are Io, Europa, Ganymede, and Callisto, and you can see those. Some of the interesting things about them. Io is one of the innermost moons, and it's one of only 4 volcanically active bodies in the solar system. So we've seen volcanoes on Io. Europa is the smallest. It has an icy surface and is crossed by many linear features, and they think there might be oceans underneath these icy surface of Europa. Ganymede is the largest. It's cratered in smoothed areas. We can see parallel grooves where we think there might have been water at some point in time. And then we have Callisto, which is the outermost, and that one's going to have the most crater impacts, and it looks an awful lot like Earth's moon. So these are the 4 moons that you can see if you were to turn a telescope or a pair of binoculars to Jupiter. Okay, so let's take a look at Saturn. On Saturn, a day lasts about 10.5 hours, and this is difficult to measure because there's not a lot of surface features in the atmosphere that we can see rotating. Its year is 29.5 years long because it does have a further way to travel, and it's getting bigger. The years will get larger as we travel out into the solar system. The volume is 763 Earths, but its mass is only 95 Earths. So this gives Saturn a density that is low enough that it would actually float in water if you were able to put it in like a dish of water or something. Now, there are 62 recorded moons, but those are ones that have been named. There's a whole bunch of smaller moons that orbit around Saturn as well, and it does has the distinct ring patterns that you can see out here. One of the interesting things is if you have a good telescope and you look, you can actually see part of the rings in the shadow of Saturn. So it looks like they kind of break abruptly there, but they don't. They continue the whole way through. So let's take a look at Uranus. Uranus has a day of 17 hours and a year of 84 years, and there's 27 moons. One of the interesting things is that while most planets are going to rotate in this general direction, we notice that this one goes this way. So it's really kind of an interesting, different phenomenon, and it changes its seasons a little bit, well, not a little bit, but in a major way. Okay, so let's take a quick look at Neptune. Neptune has a year of 165 Earth years. It stays about 16 hours, and there are 14 moons on Neptune, the largest of which is Triton, and we can see it right here. Triton is interesting because they think that it is a captured Kuiper Belt object, which means it wasn't formed at the same time as Neptune. Neptune kind of captured it in its orbit, and it'll hold on to it as long as it can. So maybe another 3 billion years, and then Triton might break free. Triton does undergo retrograde motion, and we'll talk about that a little bit later on in the term. Atmospherically, Neptune does have a dark spot here, which is a storm system, much like the red spot we saw in Jupiter. Okay, finally, let's take a quick look at Pluto. Pluto has a year length of 248 years. Its day is about 6.4 days, so that's how long it takes to spin on its rotation. It does have several moons, the largest of which is Charon. And Pluto and Charon and their interactions make it kind of interesting in the fact that it pulls Pluto's rotational axis outside of itself. So what that means is as Pluto is rotating, it's kind of rotating in a circle as opposed to rotating on a point like we saw our other planets. So because of this, because it has the moons that are so large and kind of twisting it and yanking it out of orbit, its size is so small. That's why Pluto is considered a dwarf planet. And that characteristic came to be known because we started discovering planets in other solar systems. So we wanted to define what a planet was, and Pluto did not make the cut. That's why it's now a dwarf planet. Okay, that's it for our video. As always, there will be a lot more detail in the lessons. Good luck on your quiz, and we will see you in the next video. Aloha and welcome to our video on the minor members of the solar system. In this video, we'll talk about the location in the solar system where asteroids are found. We'll talk a little bit about comets, and we will talk about meteors, meteorites, and meteoroids. So let's talk a little bit about asteroids. Asteroids are rocks found out in space, and we can see a picture of them here. Now we call them asteroids if we find them in a certain location of the solar system. So if we have our orbit of Mars here and our orbit of Jupiter here, between these two we have this large collection of asteroids, and that's what we call the asteroid belt. So when you hear us talk about an asteroid, we're talking about a rock in space, and it's located between Mars and Jupiter. Now, this should not be confused with a meteoroid. A meteoroid is going to be a rock in space, but it's not from this location. It can be from this and traveling through space. We can call it a meteoroid. Meteoroids are located outside of the asteroid belt. Okay, so next up, let's talk a little bit about comets. Comets are interesting because these are objects that are going to be orbiting the sun. They do have a distinct orbit, so they have an orbital period, so we can predict when they'll be visible again to the unaided eye, or when we should be able to see them, or actually even where we should be able to see them. When we look at a comet, what we'll notice is there's a nucleus here, and then it has this bright coma in the front part. It also has a tail of ionized gases and also a tail of dust, and what we notice is this tail of dust is always going to be pretty much facing away from the sun. Same with the ionized gases. So as it orbits around the sun, the tail doesn't necessarily trail the coma. It's going to be blown away from the sun per se. Now earlier I brought up a term called a meteoroid. A meteoroid is going to be a rock or object flowing through the solar system that's not a comet. And asteroids, remember, those are located in a certain area, so we have these other objects floating in the solar system as well. And the location from where these come are generally going to be either the Kuiper belt or the Oort cloud. And you can see with our solar system, we would follow the planets out, and out beyond the farthest planet is where we have our Kuiper belt objects. And remember, we talked how Triton might have been a Kuiper belt object that was captured by Neptune. So we can see how we have these objects here, and they can be flowing in and out and things of that nature. So they might break free from the Kuiper belt or from the Oort cloud and travel through our solar system. Most of our comets we think are going to be Oort cloud objects. So their orbital patterns are going to be like really long, and that's why we generally don't see them every year. It's going to be decades in between sometimes these comets that we see them. Now, if a meteoroid is a rock in space, a meteor is when it travels into the atmosphere and it burns up. So meteors are what we often call shooting stars. And what that'll be is it'll be a bit of debris that breaks into the atmosphere. And as it flows through the atmosphere, the friction of it suddenly encountering other molecules, and that would be the gaseous particles in the atmosphere, that friction will cause them to burn up as such. So a meteoroid is in space, a meteor is in the atmosphere, and if it were to hit the Earth, then we have a meteorite. And our meteorites, we can look here, we have Meteor Canyon here in Arizona, and that is a huge meteorite that came down and impacted and created that canyon. It's well worth the drive to go and see. Most meteorites are going to be a lot smaller. We do have some larger ones though. And then we also have these micro meteorites here that you can see. And those fall to the Earth all the time. So if you go outside and find a bunch of small little spherical, they're generally going to be round because of that burning through the atmosphere. But you can see how small they are, and they're pretty common to find. Now, we mentioned meteors are shooting stars, so there are periods where we go through these areas where we will impact with these clouds of dust and things of that nature, and that's what causes our major meteor showers throughout the year. Probably the most popular is going to be the Perseids right here in early August. And the Perseids are generally tend to be the brightest. You'll see a meteor a minute, a meteor a second. There's just a bunch of them flying out there when it peaks. But you can see that we have a whole bunch of them throughout the year. So it gives you an opportunity to go outside and you can see some of these shooting stars. Okay, so that's it for our solar system videos. As always, good luck on your quiz, and we will see you in the next video.